Theoretical part explanation DC motor electrical machinery 1 testing of DC machines, that is Hopkinson's test. DC motor electrical machinery 1 regenerative or Hopkinson's test or back-to-back test. That test has three names: regenerative or Hopkinson's test or back-to-back test. That is very important question and answer for expected exam. Hopkinson's test. This test is done on two identical or nearly identical DC shunt machines. This test is also called regenerative test or back-to-back test. The diagram shows that one of the machines acts as a motor and other machines acts as a generator. The two machines are mechanically coupled and also electrically connected by taking large amount of power from the supply. We are able to test high capacity machines at full load efficiency. The procedure to calculate the efficiency of each machine. Input power is equal to VL/IL. VL is load voltage, IL load current. Hopkinson's test circuit diagram shown in figure. That is consists of two DC shunt machines. One acts as motor, one is generator. That is coupled mechanical and connected electrically. Motor is produced back EMF and generated EMF is produced. Ammeter is used for noted IL and IAM and ISH current. Voltmeter is used for noted VL voltage. And generator side ammeter is connected for noted IAG current and ISH current. Voltmeter is noted for VG generator voltage. Switch is connected. IG is generator current, VG is generator voltage. Copper loss in motor is equal to VL ISH apostrophe M. Field copper loss in generator is equal to VL ISH apostrophe G. Armature copper loss in motor is equal to IA apostrophe M, the power whole square RA M, resistance of motor. Armature resistance of motor. Armature copper loss in generator is equal to IA power G the whole square into RAG, that is generator armature resistance and generator armature current. Input power minus total copper loss is equal to friction, windage, hysteresis and eddy current losses in both the machines. If this values is divided by 2, we get the constant loss per machine. That is constant loss per machine. Once the constant loss per machine is obtained, we can find out the motor efficiency and generator efficiency separately as follows. For motor, percentage of efficiency is equal to input minus loss divided by input into 100. Input power to the motor is equal to VL bracket of IL plus IG. That is IL is plus IG is total entered in the motor. Shunt field current. Shunt field copper loss is equal to VL ISH power M. That is ISH is shunt field motor current. Shunt field copper loss is equal to VL ISH power M. Armature copper loss is equal to IG plus IL minus ISH the bracket of whole square into RSH. Armature copper loss is equal to IG plus IL minus ISH the bracket of whole square into RSH. Total copper loss is equal to shunt field copper loss plus armature copper loss. Constant loss is equal to PC, which is already calculated. Total loss is equal to total copper loss plus constant loss. For generator, efficiency is equal to output divided by output plus losses. Graph is shown efficiency of motor and generator, shown in notes. And the generator output power of generator is equal to VLIG. Generator shunt field copper loss is equal to VLISH power G. Armature copper loss is IA power G bracket of square into RAG. Armature copper loss is equal to IG plus ISH power G bracket of square into RAG. Total copper loss is equal to VLISH power G plus bracket of IG plus ISH power G bracket of square into RAG. Constant loss is equal to PC, which is already calculated. Input is output plus total losses. Percentage of efficiency is equal to output divided by input into 100. DC motor electrical machinery 1 problem. Hopkinson's test or regenerative test or back-to-back test. That is three names that test. Kindly noted. That is important problem. Questions. In Hopkinson's test on two similar DC shunt machines or the following readings are obtained. VL is equal to 100 volt. Motor I is equal to 30 ampere. Generator I is equal to 25 ampere. Armature resistance of each machine is 0.25 ohms. Calculate the efficiency of each machine. Neglecting field current and assume that iron and mechanical losses are same for both machines. Given values is VL is 100 volt, RE armature resistance of each machine is 0.25 ohms. Motor current is 30 ampere, that is I power M. Generator current I power G is 25 ampere, that is given values. Calculate efficiency of each machine. A circuit diagram. Motor and generator are parallel, coupled, electrically connected. Under voltage supply, DC supply, 5 ampere and 30 ampere, 25 ampere. 25 ampere is generator current, 30 ampere is motor current. Solution from circuit theory, total loss is, from electrical machinery, total loss is equal to VL into IM minus IG. IM minus IG. IM minus IG is obtained from, that is opposite direction, that is from circuit theory. We learn put minus sign for IG, that is opposite direction. So 30 minus 25. 100 into 30 minus 25 is equal to 100 into 5, that is 500 watts. Loss is equal to 500 watts. Variable loss is armature loss. Armature loss is equal to IA square RA. Variable loss is IA square RA plus IG square into RG. RAG. 30 square into 0.25 plus 25 square into 0.25. Variable loss is calculated is equal to 381.25 watts. Constant loss per machine is equal to W divided by 2. That is 500 minus 381.25 divided by 500 is total loss. Variable loss is 381.25. W is total loss minus armature copper loss. Constant loss per machine is 118.75 divided by 2. That is W divided by 2. Constant loss per machine we obtain value is 59.375 watts. For motor, input power is equal to 100 into 30, 3000 watts. Total loss is equal to IA square into RA. Motor IA is 30 ampere into RA is 0.25. 30 square into 0.25 plus constant loss is 59.375. Total loss we calculated 284.375 watts. Output is input minus total losses 3000 minus 284.375. Output we obtained value is 2715.625 watts. Efficiency for motor is percentage of efficiency is output divided by input into 100. 2715.625 divided by 3000 into 100. We obtain percentage of efficiency is 90.5%. For generator, output is 100 into 25, that is 5000 watts. 25 is resistance, 100 is VL, input voltage, that is VL into VL into RA. Output is 100 into 25, V to I, 100 into 25 ampere, 2500 watts. Total loss is 25 square into 0.25 plus 59.375. Total loss 250.62 watts. Input is output plus losses 2715.625 watts. That is current is generated current is 25 square. Kindly noted into resistance 59.375 is, that is constant losses. Efficiency for generator is output divided by input into 100. Efficiency, percentage of efficiency, output divided by input into 100. We obtain value 92.059%. That is very important problem. Hopkinson's test and theoretical Hopkinson's test is very important questions answers. Thank you.